Hello scholars, welcome. Mr. Hinkle here. I want to talk about El Niño and La Niña. They're special types of weather that occur because of the ocean. Well, not just the ocean, but it's the interaction between the ocean and the atmosphere, the air-sea connection. And when we have very specific things happening along the Pacific equatorial region, then we can see very unique types of weather that are occurring that have global impact. So here we'll discuss the science of Walker circulation, El Niño, La Niña, talk about an atmospheric river and what that is, and then look at some notable events in history. So, introduction to El Niño. El Niño is a climate phenomenon that happens in the tropical Pacific Ocean. It impacts weather all around the world, and it can even have effects on broader timescales, more than just a single weather event, but affecting climate over seasons and years. It's part of a large climate cycle known as ENSO, the El Niño Southern Oscillation, that includes all three parts of what I'm going to talk about: El Niño, La Niña, and normal conditions known as Walker circulation. And so this is a good place for us to start. Walker circulation, there we go, is going to be the quote-unquote normal conditions in the Pacific Ocean. So the wind blows, and the friction of wind drives surface currents in the ocean. The Earth rotates, and because the Earth rotates, there's a slight deflection due to the Coriolis effect, creating 3 convection cells in the northern hemisphere, 3 convection cells in the southern hemisphere, and the convergence of those cells along the equator creates winds that blow from east to west. And so under normal conditions, a normal strength of the wind, here we can see from the east, this is the east of the Pacific Ocean to the west, warm water moves in that direction because the warm water that's heated up by the sun travels from east to west, meaning that the process of upwelling will replace. Upwelling brings nutrients and very fertile fishing grounds to various areas on the west coasts of South and North America. So Walker circulation is when you have normal convection cells, normal, right, that cause the majority of the water to move from east to west. El Niño switches that up. So normally the water moves from east to west, but in El Niño we have a reversal. So the winds are a little bit weaker, the pressure systems in the atmosphere change, and we get warm water that migrates. This is North America and this is South America. We get warm water that migrates to the west coast of North and South America. So El Niño, that we think of as a weather pattern. Oh, El Niño is going to bring more rain. Yes, okay, so that's weather. But what's going on actually is occurring out in the ocean, right? And it's where warm water at equator moves east. So this blocks the upwelling, lowers biological productivity, and is a big bummer for marine fisheries because fish need primary productivity. The fish are going to eat the producers need sunlight and nutrients. The nutrients are at the bottom of the ocean. If those nutrients can't make their way to the top, oh no, no producers, no fish, and no fisheries. The Peruvian fishers and the other fisheries will suffer. La Niña. So La Niña is going to be the opposite of El Nino. So here we're going to have very strong conditions, and we can see that all of the warm water, all of it, right? But basically you have more warm water making its way over to the west, creating various conditions and changing the atmospheric circulation patterns. Usually what happens here now is we have a lot of upwelling, higher biological productivity, and because the location of the warm waters at the Pacific changes, weather patterns are also going to change. But if we're thinking about the science of what's happening that causes the weather to change, what's going on here is that we have warm water at equator moves west relative to normal conditions. So the warm water we're looking at is sea surface conditions. The middle is Walker circulation, where you can see there's a gradient, but the warm water stretches mostly through half of the Pacific Ocean. El Nino, the warm water, makes its way all the way over to North and South America. And La Niña, we have more cold water over in the east because the majority of the warm water has been blown. Remember, this has to do everything with the air-sea connection. The warm water has been blown by the trade winds at the equator over to the west part of the Pacific Ocean. So El Nino and La Niña are special weather conditions that have everything to do with the location of warm water in the tropical Pacific. What we get out of this is an irregular pattern. We've been studying this for 70 years. We're looking at warm phases and cool phases that happen about every 2 to 10 years. Phases usually last a year to a year and a half, but this is very hard to predict. And ENSO might also be part of something bigger called the Pacific Decadal Oscillation, 20 to 30 years, but this is an area of intense research and study. How and where and when is El Nino going to occur? Well, we don't really have all of those answers. We've been monitoring El Nino with a system of buoys since 1985. This is actually instruments in the ocean that are recording the temperature of the surface of the ocean. Pretty cool. We're gaining a lot of information. We don't really understand all the whys and the hows. We understand the what. The what is warm water on the Pacific equator is moving in a certain direction because of changes in atmospheric circulation patterns. That has implications globally. So it's water in the Pacific. But what does that do? Well, it creates regions that are basically, the weather is going to change, bringing a lot of rain to certain areas, making other areas dry. Drier areas might flood. Wetter areas, I'm sorry, let me re-say that. In areas that are wetter, you will receive flooding. In areas that are drier, there might be fires, there might be wildlife that's impacted. You could have more storms out to sea. Basically, even though this is Pacific Ocean, which is the largest ocean in the world, an event that occurs in the tropical Pacific, the effects on weather has global impacts. That's pretty cool. So special weather, we're thinking El Nino, La Niña, and a specific type of weather event is called an atmospheric river. Atmospheric rivers are bands of water in the sky, bands of water vapor. And they originate in tropical areas somewhere around Hawaii, and so they'll also be called Pineapple Express. And they essentially deliver all the moist air from the tropical regions to the west coast of North America. Now, these are known as drought busters or flood producers. These are some of the biggest storms that we have seen, and often they go hand in hand with El Nino. When you have the conditions of warm waters that make their way all the way over to North and South America, then those warm waters can actually help to fuel these bands of atmospheric water vapor in the sky called atmospheric rivers. Atmospheric rivers in El Nino have created some significant events. 1982 and 1983. Here's Pismo Beach. If you've ever been to Pismo Beach, it's sandy. But in the El Nino of 82 and 83, the storms and the waves were so big that it just stripped and it ripped all of the sand off of the beach. Now, coastlines are dynamic features of the landscape, and they can remove sand. They can also, through longshore transport of sand located further north, bring that sand back. There's also beach nourishment, if this is a very big deal, which is where humans pay a lot of money to dredge up sand out further off the shore and then bring it back on. So, big event. 1997, 1998. This is an El Nino that I remember because I was in middle school at this time. So, widespread droughts, flooding, other natural disasters. 16% of the coral reefs died. Temporarily warmed the air temperature by 1.5 degrees Celsius. And here we can see, look at this band at the Pacific. All of this warm water making its way over, fueling huge storms. Yosemite flooded. Here's the flood level. This is like overhead high in January 2nd, 1997. I remember school getting canceled, and the street that my school was on was flooded. It was flooded like up to my knees. I had to like hike across and run home because I walked to school at that point because I didn't live very far. But I vividly remember how much it rained and being at school, and then they sent us all home because we needed to go. There's a creek. I grew up in Merced. We needed to go home to sandbag our homes because of the flooding that was occurring all over town. 2015, 2016, here we can see sandy beaches that have been completely stripped. So this beach was up here, this beach was up here, and then all of a sudden, whoa, that's a lot of sand gone. Big waves, big storms have big energy that can rip the sand off of the beach. So we see not only flooding inland, but we see coastal erosion at the shoreline. 22, 23, here's some people in their homes. This is an atmospheric river event in the town of Aptos. Here's the LA River almost overflooding its banks. Whoa, wow. These are powerful storms, very specific weather that again, all go back to sea surface temperatures in the ocean. I think the link between weather, climate, the atmosphere, and the oceans is tremendously awesome. So, historically, written in historic record, there was a 43-day atmospheric river that turned Sacramento into basically a lake. This is before the American River had levees. This is before the Mount Shasta dammed up the Sacramento River. So these rivers ran wild and free. And when they overtop, what do rivers do? They transport water, they transport sediment, they love to flood. And so now humans are really good at minimizing floods through flood regulation, water regulation. But in 1862, none of that existed yet. So big storm came in, flooded downtown Sacramento under 10 feet of water. The Central Valley is just that, it's a valley. And so, left to its own devices at various points in history, it would flood. El Niño, La Niña, very specific weather patterns. And they're an example of the Earth system and how everything is connected on our Earth. We study oceanography in order to think about the processes that are happening within the marine environment. But what's happening in the atmosphere is directly related through a series of interactions that affects the marine environment. So, the atmosphere is important, the oceans are important, the biology and the life is important, and so are the rocks, the geology, and these all work together. The lithosphere, the atmosphere, the biosphere, and the hydrosphere to form our Earth system. Thank you so much. I'll see you again.